In Chapter 5, you will learn conditional statement and loop statement in Java. Actually, this is very important in coding. First of all, I'll explain Boolean expressions. Flow of control. Unless specified otherwise, the order of statement execution through a method is linear, one after another. Some programming statements allow us to make decisions and perform repetitions. These decisions are based on Boolean expressions. We also call conditions that evaluate to true or false. So if the condition is true, then go to next step. And if the condition is not true, false, then skip the next step, something like that. The order of statement execution is called the flow of control. A conditional statement lets us choose which statement will be executed next. They are sometimes called selection statements. Conditional statements give us the power to make basic decisions. The Java conditional statements are if and if-else statement and switch statement. You will learn if statement in Chapter 5, and we will explore the switch statement in Chapter 6. A condition often uses one of Java's equality operators or relational operators, which all return Boolean results. Actually, we call all of these relational operators. They are equal to, not equal to, less than, greater than, less than or equal to, greater than or equal to. You must be careful when you use equal sign. If there is only one equal sign, it means assignment. And for equality check, you must use two equal signs. So if you want to see if two data has the same value, then you must use this two equal sign. This is equality operator. An if statement with its Boolean condition looks like this. This is if statement. When the program goes here, then at first see if this is true or not. If this is true, that is sum is greater than max, then this line will be executed. If this is not true, this is false, then this line is skipped. So according to this condition, this line can be executed or cannot be executed. And here, be careful. You don't have to, you cannot write semicolon here. I'll show you. Here, you must not have semicolon here. Sometimes students put semicolon here. Then this statement is not related with if statement. So be careful, you must not put semicolon here. And if this is true, then this will be executed. This is not true, this cannot be executed. This is if statement. Let's take a look at example. At first, the scanner is created, scan object is created, and then enter one data. And the data is stored into count variable. If count variable is greater than 20, then count exceeded is printed out. If this is not true, count is less than or equal to 20, then count exceeded cannot be printed out. So here, two running examples, I put 33, this is greater than 20, so this is printed out. But if I put 5 as input, then nothing happened here. Just skip this line. Take a look at this example. This example also receive one data, and count has that input. If count is greater than 20, then this is printed out. And then this line is not related with if statement. So this line will be printed out unconditionally. And after printing out this line, the count is compared with 30. This is equality check. If count equals 30, then count is 30 will be printed out. And this line is also not related with other if statement, the above if statement. So this line will be printed out unconditionally. So here are 3 running examples. If I put the 15, count is 15, then this does not hold. So this cannot be printed out, but next comparison will be printed out, and count is 15, so this cannot be true. So count is 30 cannot be printed out, and this line can be printed out. So only 2 lines will be printed out like this. If count is 25, then count exceeded printed out. Next comparison is printed out, and this cannot be printed out because this is false. And last line of the code will be printed out. If I put 30, then count exceeded is printed out because this is true. And next comparison will print out. And this is also true, so count is 30 is printed out, and last line of the code will print out. Take a look at one more example. At first, I received a value count, integer value count, and if count is not 20, this is not 20, count is not 20, then count is not 20 will be printed out, and this line will print it out anyway. So if I put 23, then this is correct because count is not 20. So this is printed out and this is printed out. This line is not related with this if statement. So this line will be printed out unconditionally, regardless of the if statement. If I put 20, then this condition is false. This condition says count is not 20. So if I put 20, then this line cannot be printed out, and this line will be printed out unconditionally. Boolean expressions can also use the following logical operators. There are 3 logical operators. They are logical not. We can represent logical not with this symbol, and logical and, this symbol, and logical or, we use this symbol. They will take Boolean operands and produce Boolean results. Logical and, logical not is a unary operator. It operates on one operand. This means that logical not only have operands here. And these operands should be some statement that can be evaluated as true or false. And logical and logical or are binary operators. Each operates on 2 operands. So logical and operator should have 2 operands, like in both sides. And this one and this operands are also some conditions that can have that result in true or false. This is logical or operator. Logical or operator also should have 2 operands in both sides. And the operands should be some representation of true or false. I will explain one more time. A statement that can be evaluated as true or false must be in the box, in these boxes. Logical not operator, this is the logical not operator. You should put some statement that can be evaluated true or false here. So logical not has only one operand. Logical and, this is the logical and operator. There should not be space here. There should not be space here. You must write like this. and this can have two operands. So true or false operands in both sides. Likewise, logical OR, this is logical OR operator, should have two operands in both sides. And both sides should have some expressions that can be evaluated as true or false. The logical NOT operation is also called logical negation or logical complement. If some Boolean condition A is true, then this is exclamation mark, but we just say not A is false. If A is false, then not A is true. Logical expressions can be shown using a truth table like this. If A is true, then not A is false. If A is false, then not A is true. Take a look at example of logical NOT operator. A is 10, B is 20, and here is NOT operator. Then we must evaluate this first. And this is false. Since A is 10 and B is 20, this is false. And NOT makes true. So this condition is true. So inside if is printed out like this. And this line can be executed regardless of if statement. So the last line of the code will be printed out. If A is 10 and B is 10, and if is here, then this condition will be evaluated. This is true. This is true, but NOT makes all this statement, all this condition is false. So this cannot be evaluated and printed out. So finally, only this line will be printed out. The logical AND expression is like this. And this is true if both A and B are true, and false otherwise. So to make this expression is true, A and B are both must be true. Logical OR expression is this. This is this one in the keyboard. So this is true if A or B is true. This means that this is false when both A and B are false. We will look at more detail. A truth table shows all possible true-false combinations of the terms. Since AND operator and logical OR operator each have two operands, there are two operands, so there are four possible combinations of A and B, like true, 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 false, false, true, and false, false. There are four combinations. And A and B is true only if A and B are both true. See, if A and B are both true, then A and B is true. The other cases are all false. And logical OR operator says, if both are false, then the result is false. OR operator is false. The other cases are all true. Let's take a look at examples. A is 10, B is 20, C is 15. And if a statement is like this, here is a logical AND operator. Then computer will evaluate the both sides. So this is true, and this is false. So the AND operator concludes that this is false because true and false. It becomes false. So inside if cannot be printed out, and this line is always printed out. And OR operator, A is 10, B is 20, C is 15. OR operator also evaluate both sides. So this is true and this is false. Even if this is false, OR operator evaluates this as true, because only when both are false, then OR operator results false. So at this time, inside if is printed out, and this line is also printed out. Take a look at one more example. Max is constant value 100, and using scanner, the compiler reads one integer and stores it to total. And Boolean variable found is false. And we need to evaluate this expression. Total is less than max. It depends on total. So if we put a total 99, then 99 is less than 100. So this is true. And found is false. Found is false, but not operator becomes this true. So if total is 99, this part is true and this part is also true. So keep working is printed out, and the last line of the code will print it out. If I put 150 as total value, then this time total is not less than max. This means that this part is false. If total is 150, this is false. And means that, and the operator means that both sides should be true. So regardless of this part, this is false. Okay? So keep working cannot be printed out, but the last line of the code will be printed out because this line is not related with if. If an expression is complex, the truth table is helpful. For example, the previous expression can be evaluated with the truth table like this. This is the previous expression, and this is the result of a total is less than max, and this is the found value and not found. This is just a negation of the found value. So false becomes true, true becomes false, like this. And this result, this expression depends on the value of total and max. So if this is false and this is true, then AND operator will give false, right? And if this is false and found is true, then not found is false. So false becomes false. If this is true, if found is false, then not found becomes true. So true becomes true. And if this is true, if found is true, then not found becomes false. So true, false becomes false. So when you see some complex expressions, then it is very good idea to make truth tables. The processing of and or operator is short-circuited. If the left operand is sufficient to determine the result, the right operand is not evaluated. This is short-circuited. So for example, this is AND operator. If this is true, then the right side must be evaluated. If this is false, then this becomes false. If this is true, then this becomes true. Okay? But if A is false, if this part is false, then we don't have to see this part, because AND operator can be true if both sides are true. So if A is false, then the right side is not evaluated. Actually, it is not evaluated. The computer does not see that. About OR operator, about OR operator. If this is true, then compiler does not see this part, because regardless of this value, if this is true, then this becomes true. So if A is true, the right side is not evaluated. But if A is false, then the whole result depends on the value of B. If A is false, then right side must be evaluated. Because A is false, then if B is true, then final result is true. If A is false, and if B is false also, then the final result will be false. Let's look at short-circuited operators. A is 20, B is 15, C is 33. Here, A is greater than B. This is true. This is true. So, if this is true, then the whole expression is true. Or if this is false, then whole becomes false. So in AND operator, if the left side is true, the right side must be evaluated. So if this condition, left side is true, then right side must be evaluated. And OR operator, A is 20, B 15, and C is 33. See, this is true. This is OR operator. If this is true, then regardless of this result, the whole expression can be true. So at this time, the right operand does not have to be evaluated. So if this is true, then this condition does not have to be evaluated in OR operator. And see this one, 20, 15, 33. This time, this is false. This is false. And the operator can be true only if both sides are true. So if this is false, then compiler does not see this part. Because regardless of this part, this can become false because of this. So if this condition is false, then computer does not see this condition. It does not have to be evaluated. And A is 20, 15, 33, same. This is false. But this is OR operator. So if this is true, then whole expression will become true. If this is false, then whole expression will become false. So this time, this part is very important, must be evaluated. So in OR operator, if this is false, the left operand is false, then right operand must be evaluated.